This YouTube live session में we are going to discuss the Python socket programming. Python is the language and we are going to create a socket for communication between a server and a client, and we'll try to send some messages in the form of data from server to client. And in the end of this video I will also show you that how you can basically make your Raspberry Pi as a server and your system as a client, or vice versa is also possible. That means you can make your Raspberry Pi as a client and your system as a server. So let's start. I am working on a Linux machine, so first I am trying to create a folder to write the code. Like I have started make directory command, and let's say that my folder name is socket example. So my folder is created, so let's enter into this folder socket example. Now I am inside my folder and this folder is empty. As you can say that I have run the ls command and it is showing nothing. So the next step is I am going to open my Visual Studio Code so that I can write the programs in Python language, and my Visual Studio Code is opening. Till the time I would like to say, or I would like to discuss that what is socket and where to use socket and which protocols are basically used in the socket. So socket in general is a combination of two things. The first thing is an IP address and the second thing is the associated port. So if we are combining these two things like IP address and the port, we can say that we have created a socket. Socket is a way to send data from one machine to another machine. So Visual Studio Code is ready. Now I am going to create a new file. Let's name this new file as server. So I can name this file as server.py. So in this server.py I have to create a server code so that this code is going to run on my server, whether it is my computer or it may be any Raspberry Pi or other SBCs. So the first line is, it is a server code and it is written in Python. The first thing that I have to import a Python module that Python module is socket, and I am also importing one more module, that is system module, so that I can basically plan the clean exit from my code. The next thing is I have to define the server credentials. So I am writing server credentials, and in those server credentials I have to define the IP address of my server machine. The way of knowing the IP address, there are so many ways possible that you can know your IP address, and the best way, because we are going to utilize the socket library or socket module in our Python. So let me try one thing, that is socket dot get host name. So sorry, get host name, and let's print this IP. What is this IP? So when I am running this Python script, you can see here in the terminal, you can see here that the name of host is Fedora. So this is the way I can get the name of my server or name of my any machine where we are implementing the socket. Another way is that you can run this ifconfig command in your Linux based system, or if you are using Windows based system, in your command prompt you can run ipconfig command to know the IP address of your system. So here I am interested to in knowing the IP address of my system. So again I am writing socket dot get host by name, and inside this function I am going to write socket dot get host name. So let's try to run this command. एक बार इस command को run करा के देखते हैं. Then this command is showing me that the IP address of my system is 192.168 and so on. So this is the way how we can know the IP address of our system. As I have already told you that while we are creating socket, we are requiring two things. The first thing is that we need to know the IP address of my system, and the another thing is the port. So I am defining port here as, we can take any arbitrary port. So my favorite number is 54321, and you can take any port, but just try to avoid the fixed port. Like some ports are already fixed for certain application. Like if you are using web application, then port 8000 or 8080 is fixed, or if you are using SSH communication or SSH connection you are establishing, then port 22 is going to be used. So please try to avoid these ports जो कि पहले से ही किन्हीं काम के लिए पहले से फिक्स किए जा चुके हैं. So I have decided that I am going to use this port 54321, and you can take any port of your choice. So the next two things, these are basically the global variables. So I am writing global variables, and in those global variables I am using buffer size, and I am going to take buffer size is 1 kilobyte. I will explain you that where we need this buffer size while we are communicating between the server and client using this Python or the socket module. And the next thing that I require is the format. I am naming a variable as a format, and this format I am going to use UTF-8 format. Because जब भी हम लोग data send करते हैं from server to client or client to server, then we need to encode the data. And when we receive the data and we want to print that data, then we need to decode that data. So for this encoding and decoding mechanism, we are going to use this UTF-8 format. So this is the initialization for our server. We know that what are the server credential, like IP and the port of the server we know, and we have declared certain global variables also. So it's time to write the first method of our program, method 1, and this method is to create the socket for server, to create the socket for server. So for creating the socket, I am defining this function def server socket. You may take any name of your choice, and inside this method we are going to use try and except mechanism. So first thing, we want to try to execute certain commands, and अगर इन commands को execute होने में there is any error, then exceptions may be there. This is the way how you can handle the exceptions, or you can handle the errors, or you may know that in which section of your code the error is basically coming. So here I am writing try, and in this try the first thing is I have to create a server socket. So I am using s_socket as a server socket, and the method or the command or instruction is basically socket dot socket, and here socket dot af underscore inet, and socket dot sock underscore stream. So this is the benefit of using VS Code. All these things are basically available. It is having a pretty good IntelliSense and autocomplete. So when we are basically declaring the socket, let me close this terminal for a while so that the screen will be visible, and let me make it a little bit bigger. I think that now the screen is properly visible to all of you. Okay, when we are creating socket, then we can use this method socket.socket, and inside this function we have to tell two things: the socket family, whether we are going to use Unix socket or IPv4 based sockets or IPv6 sockets, and the type of socket, like which protocol we want to implement. So generally we are using socket family is IPv6 based, so I am using socket.af underscore inet, and we are using TCP communication protocol, that's why we are using sock underscore stream. And if we are using the UDP sockets, then these things are going to be different, especially the socket.sock_stream is not going to be present here. We have to replace this thing with the UDP socket type. The next thing is, let's say our socket has been created properly. The next thing is we need to bind this socket with a particular port. So you remember that we have declared this port 54321. Now it is time to bind this socket with a IP address and port. For this thing I am using s_socket, this is the name of our socket, dot bind, and inside this we need to use a tuple. So if we are using tuple, I am writing IP comma port. This is basically the socket address for the server. So I have we bind the server socket with the IP and the port that we have defined here. The next thing is, now our socket will start to listen the client. So we need to define that how many clients our socket can listen, and for this purpose I am again using server socket, that is ssocket dot listen. Inside this bracket you can write any number, and that means those many of clients will be available or waiting in the queue to putting their request to the server to listen. So now our socket initialization or creation of server socket is complete. We just want to print a message for the users so that they may know that our socket is running. So here I am using functional string, and I can write that server is ready to listen, clients at, here I just want to show that what is my IP address. So I am putting IP address and the port, just for the user information whosoever is handling the server. So this is the way that how we can create the socket, and if any error occurs during this method of creating the socket, one more thing that okay, if any error occur, then we need to handle those errors. Except socket dot error as E. I am naming this error as E, and I need to print again I am using functional string, this error in creating socket, and this error is basically, I just want to print this error into the form of a string. So I am typecasting is this error. So this instruction will print that there is an error in creating socket. So the user or the programmer will know that where the error is basically generating, where the exception is basically generating in his or her code. So the next thing is, if error has been generated, you just want to exit from this server code. For this purpose I am writing sys.exit. The next let's say that our server is continuously running, and we want to log out, or we want to shut down our server. So for that purpose we are going to use the keyboard exception or keyboard interrupts. Again, accept keyboard interrupt, and I am print that server is closed due to keyboard interrupt. Okay, now this thing is good, but it is a function, and we need to use this server socket in some other function. So we have forgot that we need to return the value of server socket. So in this try block, in the last line I am writing return s socket, So this method is complete, this function is complete now. And one more thing, that sys.exit. So this will we are planning to exit cleanly from this method or from this server program. So this is the method, or this is the function how we are basically creating the server socket. The next step is that we need to write a function so that we can handle the client messages, we can receive the client messages, and we can send them back the acknowledgement for those messages. So for handling, we are creating here a simple echo server. Echo server means whatever the message client is sending to the server, server will receive that message, it will print those message in its own console, and it will return the same message to the client. If the client is receiving the same message, that means client will understand that its message has been successfully delivered to the server. So for that purpose, I am creating a function again for echo server operation. So again I am creating a function, and let me name this function as echo server. The next important thing is, whenever we are basically writing this function echo server, we need the server socket. So let's say this server socket is S here. We are basically providing or passing a parameter into this function. So in this function, the thing that we need to do is we want to run this function forever. Like if one client is connected with the server, it may be able to send messages to the server, and if that client basically now is not available, or the client has been switched off, or the log out or shut down, then next client may be able to connect with this server. So our server should remain online or should remain available for all the time. So here we need to run a while loop or a forever loop. So for that thing I am writing while true. So whatever the instructions we are going to write down here, they will continuously run until we are breaking this while true loop. So inside this loop, again I am using try and exception mechanism or the block, and in this try block, the first thing that we need to do, we should accept the connection request. Like if client is basically sending a connection request to the server, then server should accept the connection request from the client. For that particular thing, now I am writing my name, server socket name in this function is s dot accept. When we are running this accept function, it will return us two values. The first thing is the client socket address, and the second thing also is the client socket IP and the port number. So we are naming it C underscore socket and C client address. So if we are running this server dot accept or s dot accept function, we are going to receive two things. First one is the socket for the client. This is basically represented here C underscore socket, and the second thing is C underscore address. So now let's print these values, so that when we will run this code, we will be able to know that what is the client socket and what is the IP address and the port address of the client machine. So again I am printing this thing, print using the functional string, and I am writing client. Here I am using C underscore address. It is basically available in the form of list. So the first element or the 0th element is basically the IP address of the client, and I am putting a colon here. Again I am writing C address 1. The next element of this list is basically representing the port number of the client machine. So I am writing here a statement, I am printing here a statement client this from this IP and this port is connected. So this is the message we will be able to get know that this client from this IP and this port number is now connected with our server. The next thing is, now one client is connected. We are not using the multi-threaded server here. It is a very simple server. So at a time one client may communicate with this server. once that client will communicate with the server and it will decided to exit from this communication, then the another client may be able to join this server. So the next thing in this try block, again I am using a indefinite loop while true, because we want to remain this channel available until the client is decided that now it don't want to communicate with the server, it don't have any data to send to the server. That's why I am using while true loop. And again I am writing try and except block, try, and in this try I will receive the message from the server. So the message received will be stored in this message variable, and to receive the message from the server we generally use C underscore socket. It is the client socket. Remember here when we have accepted this connection request, we have got the client socket dot receive. While we are receiving, we need to explain, or we need to define that how much data we can receive at one go. That's why I have created two global variables, a buffer, and here I can show you we have created two global variables, buffer and the format. So this buffer is basically telling us at one go we may be able to receive 1 kilobyte of data, that is 1024 bytes we may be able to receive. So I am just putting here buffer. So this much of data we may be able to receive when client is sending the data to the server. Now this data is in encoded format. If we want to print that data in our console, we need to decode that data. So to decode that data, in the same line I am using decode, and in which format we want to decode, we have already defined the format is UTF-8. So this is the way how we can receive the data from any client machine, and we can basically store that data into the format of into the any variable. The next thing is if not message, like client is not sending any message, client ने भी कोई message आपको send नहीं किया, then what to do? If client is not sending any message, then we need to break this continuous loop. So we are breaking this loop. If client is sending some message, we server ने कोई message receive किया, then what we need to do, that we need to print that message onto the server console. So I am using print, and again I am using functional string. I just want to show that किस client ने message server को send किया. तो client की identity जानने के लिए we need to print the IP address of the client machine and the port of the client machine. So again I am printing here the IP address C underscore ADDR and the 0th element of this list, colon, just to display it properly I am using this colon, and C underscore ADDR 1. I am putting these two arrows. So it will be displayed like this IP, this port, the message. So I am putting here the message. So this is the way we want to print our message to the server console. The next thing is it is a echo server, and if it is a echo server, then it should be able to return back the same message to the client. So if we want to send the same message to the client, what we need to do, we are again connecting with client using the client socket dot send, and inside this send we are writing the message that we have received, and this message is basically stored into the MSG variable. Then if we are sending anything to the socket using the socket, then we need to encode that message into a specific format. So here we are using encode, and inside the encode I am using the specific format, that is UTF-8, that we have already declared as a global variable. So this function client socket dot send will basically send the message, the same message, it will basically echo the same message to the client machine. So now this complete process has been completed. Now we have to handle error. If anything is going wrong, अगर इस second while true loop के अंदर कुछ भी गलत होता है, there is any exception, there is any error, then we need to handle those errors. Again I am using except socket dot error as E, and inside this I am printing print using the functional string. Of course, this error is basically where while we are communicating. So this error is from echo server, echo server error. And what is this error? Again I am typecasting this error in the format of a string. And if there is an error, certainly we want to break this a while true loop, this second while true loop, where we are basically communicating with the client machine. So I am putting a break statement here. Fine. Now if we want to close the connection, because it is an indefinite loop, it is continuously running, and if we have decided that now we are not able to, or we are not going to receive the data from any client machine, we just want to close down our server, then again we can use the keyboard interrupt, except keyboard interrupt, and again I am printing exit due to the keyboard interrupt. Fine. And again I am putting a break statement here. So this is the method how we are basically handling the error inside this while true loop. Once this while true loop has been completed, if let's say a simple scenario is my client is not sending any data, so we have to break this while true loop. If we have अगर हमने इस while true loop को break कर दिया, then in the next step we are again into this first while true loop or first indefinite loop. In this loop we are basically ready to accept the connection request from the other client machine. And if something goes wrong inside this, because already इस loop में भी we have used the try and accept block, so I am writing this accept and keyboard interrupt statements again in this block. So let me quickly format it. Okay. So again I have written the same thing, the same statements here to handle the errors in our server. So I think that my server program is completed by now. The next thing is what will happen if we are breaking these loops. So all the loops have been broken. Now after the break statement, we have to write certain statement that we want to execute. So after the break statement, I'll come here and I will basically close the server socket if it is already open. So the server socket is S and we are closing this socket, server S dot close, and we want to exit from the system. So I am writing sys dot exit. So we have written the two functions or two methods in our server code, and the next thing is that how these two methods or functions are going to run. So this time I am going to be an old school and I am using if underscore name is equal to main. Then the first function we need to run is our server socket function, server socket. Fine. But remember, server socket function is basically returning something. So we need a variable to store that return value. So I am using S here. So the server socket will return the server socket value, and I am going to store this value into the S variable. The next statement in this function in this block should be that we need to run this echo server. Echo server, and inside this echo server we need to define that what is the server socket address. So this program is completed by now. We have successfully written the code for our server. Let's quickly try to run this code and see. Okay, my code is perfectly working perfectly fine. That server is ready to listen clients at this particular IP address, and this is the port number 54321. That is my personal favorite port. to communicate with the clients and the server. That's fine. So the half part we have completed here. The next thing is we have to write a code for a client machine. So for writing the code on the client machine, again I am opening a new file and I am naming that file is client.py. In this file we are going to utilize certain things from this server file, and let me copy these statements from the server file here. And it is not a server, it is a client code. So I am replacing the server with the client here. Again I need to import socket, I need to import sys module, and I need to declare the IP of the server, because client should know the server IP address and the port address so that it can correctly send data to that particular socket. So since I am working on my machine, it is acting as a local host. I am going to run the server and the client both on the same machine. I am using the same mechanism here, socket.get host by name and socket.get host name, and the port of the server is the same. So now the global variables, I think that you remember here that what are the global variables and how to use those global variables, why we are basically declaring those global variables. Like the server program, remember the first method that we have created to create a server socket. Similarly, in this client program, I am creating a client socket. So creating a client socket, let me name it client underscore socket, and the thing we are going to use try and accept things. So try, the server socket is basically C socket. I am naming it here as a C socket, and I am using socket.socket command, socket.socket, then socket.af underscore inet, and socket.sock underscore stream. So my client socket is connected by now. The next thing is, when we were doing the server code, we were trying to bind that server socket with the particular port and IP address. Here we don't need to bind that client socket to any particular IP address or to any particular port. Here the thing that we need is to connect this socket or connect this client with the server. So for that purpose I am using C underscore socket dot connect, and inside this connect I can write, again I can use the tuple, that is IP and the port. So this way our client is now connected with the server, and to prove this I'll use a print statement, simple print statement, that connection established between client and server. So my connection has been established, and again we need to return this client socket so that we can use these things. The next thing is we need to handle the exception, and if we are handling the exception, we are talking here only two kind of exceptions only. These are the socket error and the keyboard interrupt. I am copying these things from my server.py file and I am pasting these things here. So this basically completes the code for client underscore socket function. The next thing is, again we need to define a function that will basically cater the need of sending data to the server and receiving the acknowledgement message from the server. For that thing, send and receive function is needed, and I am basically defining this function send underscore receive, and inside this function I need to use a client socket, and I am naming that parameter as C. So in this function again we need to define certain things, like we just want to communicate with the server continuously until the client has decided to end this communication channel. So again I am using endless loop or the infinite loop in the form of while true, and inside this while true I am going to use try and accept things, try again this client socket is basically c dot send, and we need to send any message. And here I am not basically determining any message here, I am not fixing any message here, I am giving this liberty to the user that they can type anything, and whatever they will type on their keyboard, that message will be sent to the server. For that purpose I am using input command, and inside when we are using this input command, we can write anything on our terminal, and that message basically will go into the to the server, because we are using this input function inside the client dot send. Remember one more thing, that whenever we are trying to send certain data to the server, we need to encode that data. So whatever the data will be available from the input, we need to encode that data into a specific format. So this is the way how we are sending data in this particular example. In IoT, when we are using these kind of things, then we need to get data from the sensors, and that data will be sent basically to the server. But here I have not connected any sensor with my system, that's why I am basically giving user this liberty to send the messages to the server. The next thing is client has already communicated its message, now it is waiting for the acknowledgement message. So this is basically to receive the message from server. So to receive the message from the server, we are going to store this message into the MSG variable. MSG is equal to c dot receive, and when we are receiving anything, we need to first define that what is the size of that data. Size we have already defined in the form of buffer, and we need to decode that data, and for decoding that data, decode again format. So the message, echo message is basically received, and we now going to print that echo message on the terminal of our client machine. So here I am writing print functional string, that is the echo message, and the echo message is basically MSG. Okay, so this thing is basically completed. Now our client is sending data to the server, and it is continuously receiving that message at its own end, and it is printing on its own console. Regarding the error exception, I am again using these same things that we have used earlier, Control C, and here I am going to put those things here, and let me quickly format this thing. Indentation correction is required. Okay, and this. The important thing is that if any socket error is basically coming, we are not exiting from the system immediately. So we can write, instead of system.exit, we can write it break. We are breaking this indefinite loop. The same thing we can do here if user is basically pressing the keyboard interrupt. Control C is the keyboard interrupt. So again I am using the break. Now once break has been reached, now we need to close the socket. It is always advised when you are exiting from any machine or any system that please close that socket properly. So I am using c dot close because the socket is C in my case. So I am using c dot close, and now I will exit from the system sys dot exit. So this code is again complete. We have written all these two functions which are required, and again to run these functions in a particular order, I am again using if name is equal to main, and the first function was client socket. So I am writing it C as client underscore socket, and the second function was send underscore receive. So I am writing it send underscore receive, and inside this I need to pass this parameter C. Let's save this code again. So my code of client and the server both are present here. Now we need to run this code on my local machine first to show you that how these programs or the client or server things are basically working. So let me open my terminal and clear this console first. This is my first terminal. Let me shrink it a little bit or open a new window here. Let me adjust these two things properly. Okay. So I am in my directory socket example. If I am pressing ls, then I can see that there are two programs saved inside my directory, client.py and server.py. So let's say this the left hand side of terminal is basically representing my server machine, and this right hand side terminal is representing my client machine. So to run the server.py code on the server machine, I am using command Python3 server.py. Oh, already in use, then we have to wait. Okay, go to the terminal. Let's say that this terminal is already working, so let me exit from here and close this thing. Again opening this thing. Now this time we have got this message that server is ready to listen clients at this particular IP address, and here we need to run in the right hand side of terminal, we need to run the client.py program. So again I am writing Python3 client.py. As this script is running, we have got the message at the client end that connection is established between client and server. This is the exact message that we have written inside our code, and here you can see here that client is available at the IP address 192.168.37.160, and you can basically see that the IP address of my server is also same 192.168.37.160. That means we are running both the programs on the same machine. The important thing is the server is basically bind to this particular port 54321, but the client has selected its own port automatically, that is also known as amorphal port, and this port is this time 60438. So let's try to quickly send some message. I am writing hello, and again this client is basically sending this message. This is a server screen, remember, and it is displaying the hello message, and it is also getting the echo message in the form of hello. Then welcome to Akgec. Again we are getting the same echo message. Let's do one more thing to understand the concept more precisely. I am going to open one more window here of my terminal. This is the new window of my terminal, and here again I am going to run a new client. For running a client, I am writing Python3 client.py. This client is also connected, but in the server side we didn't receive any message. Why it is happening? Because we are not performing the multi-threading in our server. So server at a time can listen only one client, and this second client is available in a queue. Let's try to send some message here that this is IoT class. This message is again not going to received by the server. Let's do one more thing. I am sending the message from our first client which is already connected, and you can see here that the new message is hello again. This client is communicating with this server, but when we are using our second client, this is not communicating with our server. So let's do one more thing. Let's terminate this client. Let's end this communication from the client number 1. For terminating, I am pressing Ctrl C, and if here you have got the message that server is closed due to the keyboard interrupt. This is because of I didn't change that message while we were copying. It is basically client is closed, so I will quickly fix it later on. Now the important thing is as soon as जैसे ही client number 1 close हुआ, as soon as client number 1 is closed, we have got the message from the client number 2. Here you can see that this client number 2 is having the same IP address, but the port address of this client is different. My first client were having port address 60438, and this is having a different port address. That is basically showing that this is a different client, and whatever the message it has tried to deliver to the server, that message is now received, and server has echoed back the same message to the client. So if anybody want to get rid of this problem, if you want that all your clients should continuously send or receive data or communicate with the server, then you need to design or you need to code a multi-threaded server instead of simple server. Okay, that multi-threaded server definitely we are not going to cover in this class, but later on we can cover if you put any request regarding this same. So this is the thing. Let me close down this server again. Okay, this server is closed down. Again we are back into our code, and this is the client, and if it is client, then it should say that client is closed due to the keyboard interrupt, and it should also say as client is closed due to the keyboard interrupt. Okay, we have fixed that problem that we have faced right now. The next thing is that we need to implement the same concept with the help of Raspberry Pi. So if we need to implement the same concept with the help of Raspberry Pi, let me show you that I have connected my Raspberry Pi. This, let me show you. This Raspberry Pi is basically, this is the Raspberry Pi board, and we have mounted a simple touch screen display over this Raspberry Pi, so that we can access the GUI or the user interface of this Raspberry Pi OS on this beautiful display. So I have connected this Raspberry Pi through a headless connection. This USB is basically is used to power up this Raspberry Pi board. So I am going to transfer my files, that is server and client, to this Raspberry Pi. So to transfer any file, first we need to access the Raspberry Pi, and let me clear this terminal console first. Now we need to access the Raspberry Pi, and I am using SSH connection for that. SSH pi at Raspberry Pi .local. This is the IP address of my Raspberry Pi. Now it is asking me what is the password of your Raspberry Pi. Let me type the password, and now you can see here, earlier the console was saying that I am using this machine, that is Himanshu at Fedora, and now it is showing that I am using this machine Pi at the rate Raspberry Pi. So let me clear this screen first. This is the Raspberry Pi. You can see while implementing this ls command what are the different folders available inside my Raspberry Pi. So the thing is that we need to transfer these files. Let me open one more window here, one more terminal here, clear this thing. Okay, we need to transfer all these two files into my Raspberry Pi. So let me check that what is the present working directory, that is home/pi, and let me create one more directory here, mkdir, and the directory name is socket test, and this is cd socket test. This directory is empty here. So now I am inside my new directory that is available at, you can again check what is the path, that is home pi socket test. So here if I am doing ls, then I can see that we are having two files, client.py and server.py, and let me copy these two files one by one to this new folder of Raspberry Pi socket_test For this purpose, I am going to use scp command, that is secured copy scp, and the file name is let's say server.py, and I need to use pi at raspberry pi .local, then the root folder is home, then pi, then socket underscore test. Press enter. It is asking me the password of raspberry pi .local. This is basically representing the IP address of my Raspberry Pi. Raspberry Pi .local is the IP address of my Raspberry Pi. Let me type the password here. Done. That it is showing that this server.py file has been copied into this socket.test folder. Let me check it. Yes, this server.py file is available here. The next step, I have to copy the same thing, but this time the name of file is not going to server.py. I am copying client.py file to the same location. I am putting enter. The password for my Raspberry Pi, and again if I am doing ls, you can see here that client.py and server.py both files I have transferred to the Raspberry Pi. The next thing is we need to run these files if we want to create, if we want to basically make our Raspberry Pi as a server and we want to make our computer or our system as a client. So we need to edit those files first. We need to know what is the actual IP address of my Raspberry Pi. So I am writing one command, if config, and here I may be able to see that the IP address is 192.168.37.166. Let me copy this thing here and let me open this server code in this Raspberry Pi, sudo nano server.py. This is the server code, and instead of this instruction I am making this instruction as a comment. Okay, let me remove these lines from here and let me put the IP address. What was the IP address of my Raspberry Pi? X save. Let me again see the IP address. If config, that is 192.168.37.166. So 166. So I have updated the IP address here. Let me save this file. Okay, now this file has been saved, and let me run the server into the Raspberry Pi. So to run the server, again I am using Python3 server.py. Okay, the server is ready to listen client at this particular IP address, and this is the port address. Now while let me come into my computer screen, and in this screen let me first edit the code for client. Okay, so client code is available on my computer, and let me try here. Let me make this comment, and again I am writing IP is equal to the IP address of Raspberry Pi, that is 192.168. Let me see what is the IP address, 37.166. Okay, 37.166. So I have updated this code here. This client is not closed yet. Done. So let me run the client script Python3 client.py. Here you can see the client is my machine, that is my computer, and this is a Raspberry Pi. Here you can see on the top of these headers of these terminal that this terminal is basically representing the Pi, Raspberry Pi, and this terminal is representing my screen, that is my system at which is running at Fedora Linux. So connection is established between client and server. Let me send some message, hello. It is basically received by the Raspberry Pi, and the next message is thanks for joining this live class. Okay, this message is also delivered. So with this, let me conclude. This is the basic of TCP socket programming, and I am using Python language here, which is very popular while we are implementing the Internet of Things concept, or we are basically trying to IoT to be implemented with some IoT devices or some embedded systems like ESP32 or other microcontrollers or processors. So this is it for the day, and next time I am sure that I am also available for some good topic with some good topic of your interest. Let me see the comments from here. Thank you, Rohit ji, very informative session, and I want to train by you offline. Thank you very much. Let me tell you that we provide the offline training, and in those training you can easily contact us while sending some comments on those videos. You can easily contact us, and we will basically tell you the course content of those training programs and the other things. And grow Bharat, love from IIT Dasna. Thank you, Bharat. And I am sure that I am receiving the response from you guys. It will remain the same. Stay safe and happy learning.